of these pastures that are growing kind of native plant populations, I look at how they respond to different management that we do, and I also study grazing management. And so today I'm just going to share a little bit about how prescribed fire can fit into other things that we're doing on the land, and specifically how it can work with livestock production. I'm not going to talk a lot about prescribed burning techniques today. We have another gentleman that works a lot on that, but I'm going to just kind of talk about how it can fit with other management. So there's kind of three things that are pretty important for managing land in Oklahoma, and one of those is trees. Historically, we had a lot more prairie across Oklahoma than we do now, and that's because our trees have kind of spread out from where they grew historically, and we'll talk about why that has happened. Another thing that we have to consider if we're managing for livestock is stockpiling for drought, because it's not if it's going to be dry, it's just kind of when. So we can do that actually using prescribed fire, and that might sound silly, but I'll explain how it works in a little bit. And then the last thing is that we want to try to manage our grazing distribution, so where the animals are grazing, and manage for having rest occasionally in those pastures. So those plants get a rest from grazing every now and then. And we can do all of those things with different types of prescribed burning management. And so I'm going to explain a little bit about that. So as we have tracked what's going on across the southern Great Plains, we can see that the tree cover has dramatically changed, even just in the last 40 years. Actually, we know that trees have been spreading across our rangeland pastures for more than 100 years, and so historically there weren't nearly as many trees as there are now. This is showing in 1986, the dark areas are areas that had a lot of tree cover, and you can see how the state has changed when they looked at this remote sense data from satellite imagery in 2020. There's a lot more trees. It's a lot denser than it was historically. And in Oklahoma, we know that there's been a fair amount of loss of productivity of our forage species. And this might seem like, well, we're not only managing for cattle. Well, that's true. We're managing for lots of things, but when we have trees taking over, that it can also take the place of habitat for different wildlife species that are relying on grasslands and open areas. And so here this is showing, what has happened in the last, since 1990. In the year 2019, I looked at the information, and we've lost about 4.4 million tons of forage due to just trees. So that's not due to a drought, that's just due to the trees that have taken over areas that weren't forested historically. That's equivalent to 7 million round bales if you were round baling that area, and it's equivalent to enough forage to sustain 197,000 cows year-round if we were grazing those areas that had been taken over. The loss is dramatic, particularly when you look over a long time period, just how much forage we've actually lost. This is from a webpage called The Yield Gap. Working Lands for Wildlife has this available, and you can actually look, if I can push the buttons correctly, you can actually see that this is happening in pretty much every county except a couple of our panhandle counties. And so even in Nowata and Craig County, we are seeing a reduction in the production of our rangeland pastures. Another thing that is a concern for us, particularly when it's eastern red cedar trees that are moving into our pastures, is the wildfire volatility that happens when we have those trees. Those types of trees have oils in them that, particularly if it's been really dry and the tree has a very low moisture content in it, when we have a fire that burns through, they light very easily. And so this is showing just how far you can have a spot fire travel if you're in a grassland. It's about half a mile that a spot fire could possibly travel. And that's because the embers from a grass are going to be very different than the embers that are coming when you have cedar trees that are mixed in. So then in an encroached grassland with some cedar trees, embers can travel 1.1 miles, and then when you have a cedar forest, basically, you can have embers that will travel as far as 2 miles. And so we experienced this, about a week, it'll be like a week and a half ago, with all the wildfires that were happening. Some of those eastern red cedars were burning, and the embers were moving great distances as that happens. And so we get nervous when we have these types of fuels that can really move a long ways and put a lot of land at risk. Oops, I keep going the wrong way with these, I'm sorry. This is an image of a tree that caught on fire. This is in western Oklahoma. We have a research station that's south of Clinton, and we were doing a prescribed burn there. We were burning this grass, and the flame lengths are about 6 feet tall. This was little blue stem, but you can see here the cedar tree that caught in our burn unit had flames that were 25, 30 feet high. So that's one of the reasons that you can have this happen. I'm going the wrong way. Eventually I'll figure it out. Another thing that we have with trees is movement of insects that carry diseases. So we know that as trees have expanded, particularly eastern red cedar, we have an increase in ticks. And so that's a concern for us because they're carrying things like Rocky Mountain spotted fever and other diseases that can affect humans as well as livestock. This is research. All this research has been done in Oklahoma, and another thing that they found is that mosquitoes are actually moving west as well as trees are moving. And so areas that have more cedar trees are going to have more mosquitoes. And not only are they going to have more mosquitoes, but they're going to have more mosquitoes that carry West Nile virus. So these are all things that we do not want, spreading to a greater degree than we already have them in the state. It's pretty dangerous for folks. One of the reasons that this is that both ticks and mosquitoes actually dry out fairly quickly if they're in a grassland, and that will kill them when the temperatures are really hot outside, but they can thermoregulate in a cedar tree, so that protects them from getting stressed from dry conditions. I am sorry. We'll get it figured out. All right, and then water. We lose water when we have eastern red cedars just because they're evergreens, so they're evaporating water, respirating water for a greater proportion of the year. They have a higher water demand, and so we have less water in our streams, less water in our ponds. So those are all things that we are concerned about. In addition, historically, we had a lot of shelter belts that were being planted, and eastern red cedar was planted a lot ornamentally. And so that has increased the seed load just in the environment. We have a lot more seeds around to grow. Actually, after the Dust Bowl, there was the goal to plant trees from Canada to Texas, and they were fairly successful. They planted 220 million trees in 1 year. So they were industrious. I will have to give them that, but that is impacting our land now. And so this is actually from an old OSU extension manual where we have different trees in this shelter belt. We have Osage, orange or bodark, we have hackberries, we have American elm. Well, those are all native, so that's okay. They're probably not going to cause too many problems, although they do spread into our pastures. But then we have honey locust, which is native to part of the state, but shouldn't be growing everywhere that it's growing now. And then we have Chinese elm or Siberian elm, and all of these trees are causing issues in our pastures today. And then this image down here is a cedar shelter belt. Of course, cedar shelter belts were very successful, and so they were used a lot across the state. So what was happening historically to control these? Well, fire was. Fire was what was controlling a lot of these different plants. It was killing a lot of these trees when they were small. This map actually shows the historical return interval, how frequently an area was burning. And what we know is that most of Oklahoma was burning anywhere from every 2 to 10 years. So most of Oklahoma was burning every 4 to 6. So the same spot would have a fire about twice a decade. And so fire is just innately part of these systems, and when we've tried to keep it from happening, then we build up all these fuels, and then we have really bad wildfires. And so you might ask, well, how would somebody actually know that the fire was happening that often? Well, we know from tree ring fire scars. So they've actually cut trees and looked at how frequently that tree has fire scars. And the trees in Oklahoma have lots and lots of fire scars. And so post oak and blackjack oak are two really fire tolerant tree species. And so we can look at those trees and see how many times was this tree experiencing fire. And so we've done that in quite a few places. Keystone Ancient Forest, they found that the historic fire return interval from 1772 to 1830 was that it was happening every 5 years. Let's see, this is from Okmulgee Game Management Area. It was happening every 6 years for about the same time period as this one. And then the Nickel Family Nature and Wildlife Preserve every 5 years. So every 5 years, every 6 years, that's kind of the normal, or was kind of the normal. Of course, now we have much less fire happening. And this is what those fire scars look like. This is from a tree in New Mexico, a ponderosa pine, another highly adapted fire-tolerant tree species, where they're showing how frequently fire is happening. This is from a post oak, and this post oak was actually from Wichita Mountains. And so Wichita Mountains had a lot of fire down by Lawton. There was a lot of fire happening there, even more than up here. Historically, and so you can see these are all different scars from different fires, and so they can figure out what year those were happening. They cut the tree down, they know what year it was when they cut the tree, and then they can actually count back on those scars and actually look at when the rings have scars. Okay, so I'm going to skip this one. I put too much information in here. So you might ask, how could we manage grazing and fire? Because what we're burning is the grass, what we're grazing is the grass. And so it becomes complicated. How do you make sure that you have grass for your cattle if you're burning it? Well, one approach is that you burn early in the spring before everything starts growing, and then you can turn your cattle in as soon as it starts to green up. And that has worked really well in a lot of the Flint Hills of Kansas and this part of Oklahoma and Osage County. But one of the things that we found was that then if you have a dry spring, you can be limited on how much forage you grow for those cattle. So another strategy is instead of burning your entire pasture, you just burn a portion of that pasture. And when you burn a portion of that pasture, cattle are going to focus their grazing on that burned area as it regrows, and they're going to leave the other areas alone. And so we can get rest from grazing in the areas that haven't been burned, and then we get heavy grazing in the area that has been burned. And you might say, well, that sounds like it might hurt the grasses. And what we know now from the research is that these grasses are highly adapted to this because it's been happening to them for thousands and thousands of years. So this is showing cattle occupancy. The dark colors are where cattle spend a lot of their time. And so in this pasture, they burned the whole pasture every year. And you can see there's not an area that has like a really dark spot because there's not a certain area that the cattle really, really preferred. But in the bottom pasture, they divided into 3 burn units. And in the year 2010, they burned this north unit. And the cattle occupancy is very dark there. So the cows were spending a lot of time on the burn patch that was burned in 2010. Then they moved the burn down here to 2011, and the cattle followed the burn. And then they burned 2012, they burned this patch, and the cattle moved around. And so what that does is it gets concentrated use in one spot, but rest in the others. So what might this look like in a pasture? Well, this is one of our research pastures where we do this strategy. It's called patch burn grazing. We don't put any fences between our burn patches. We just burn a part of a pasture. And so we had burned this chunk. This is about a 20-acre area that we burned. The cattle are in there year-round. They're in there when we do the burn. And then the next year, in March, we'll burn this next patch. And then the next August, we'll burn this patch. And the next March, we'll burn this patch. And so we just rotate the fire through the pasture. And that rotates our cattle grazing without having to use any additional fence. And so that gives us really nutritious forage in the burned area, but it makes sure that if we end up with a really dry year, we have plenty of forage to support them in the other patches. The only thing is that you just have to make sure that you burn another spot to keep them moving around. So I'm going to show you what, do you mind pushing, I don't know if that will work. I I have a little video of us doing some burning in Stillwater. And we did this with students, so not to downplay our students, but if we can do it with a bunch of students, I know other folks can do it too. So we have a mowed, well, this is a ranch road. It's a gravel ranch road, but then we mowed along the edge too. And we wet it down on the edge before we light. Then the pasture went ahead and regrew. We burned this in August. It kept growing through the fall, and we measured the forage quality in October, end of October. So in the end of October, we had 11% crude protein right here in the recent burn, and only 4% in the area we had not burned. So that's really good forage quality for that time of year. So when we measure the quality of the forage in those areas, we get a pretty strong response. So this was in a patch where we had burned in April, and the quality was very high. And it's generally fairly high in the spring anyway, but when you burn it, it bumps it up even higher. And then it just continues to decrease as the summer progresses. July is usually hot and dry, and so the plants start to kind of dry out. So then we go ahead and burn another patch, and we can either do this in June, July, or August. But that gives us time for that patch to start to green up. We generally get rain again in August and September, and so then that bumps the quality high later into the fall than if we had it just unburned. And so we're trying to minimize how many months we're providing protein supplement to those cattle by providing really high quality forage in the pasture. And so we tracked how many months we needed to provide supplement, and what we found was that we could provide supplement for only 3 months during the winter for our mature cow herd versus 5 months for our mature cows that were in pastures that didn't have patch burning. So we basically reduced the supplementation need by 2 months by using it. In addition, we had no difference in their reproductive performance, their body condition scores, or the calf weaning weights of the cows that were in the pasture with the reduced supplement feeding. We've also done this with yearlings, so stockers that were grazing on rangeland in western Oklahoma, and we did it for 10 years. This is a 10-year study that was done before I came to Oklahoma, but they tracked what the cattle weight gains were in those pastures, and you can see this up-down movement that's happening. We see that all the time with our livestock performance because of the rainfall differences. So when we have rainy years, we get better performing animals. When we have drier years, they don't gain as much weight because the forage isn't growing as rapidly. So anyway, so they started out not having a lot of differences between the cattle that were in the patch burn pastures, these ones that are dashed, versus the cattle that were in unburned pastures. But as the study progressed, they started to see pretty dramatic differences. So over the grazing season from March through September, they were getting anywhere from 40 to 60 pounds of additional gain on the cattle that were in the burned pastures versus the unburned pastures. And this is in agreement with all of the research that's been done in Oklahoma and Kansas with burning in general, is that you get additional gains when cattle are grazing on burned forage. So there's now been over 180 studies done on this type of management, And it's not only been done looking at how the cattle respond, but how lots of different wildlife species respond to this type of management. And so we now know that you can increase the forage quality. The grass grows more when you burn it, so the quantity of grass that you get generally increases. You can increase your weight gains. You can reduce your supplementation needs. You can not have to destock as much during drought because you have that stockpiled vegetation and the unburned patches. And then we've also seen a decrease in horn flies and ticks because cattle are spending most of their grazing time on a recent burn. So there's very few external parasites living in those areas that have been burned. I'm going to skip this one. Basically, this is showing that you can stockpile that vegetation in the old burns, create grass banks. Another study that we did in western Oklahoma is we put GPS collars on cows. I do a lot of this type of research to try to figure out how cows are picking different areas and pastures to graze. And so we put GPS collars on cows and we tracked where they grazed. We found the areas in the pasture that they were avoiding, that they didn't like, and we burned those areas. And after we burned those pastures, we put the cows back in the next year, and the cows actually increased their use of the avoided areas by 10 times. And so basically we could just manipulate where the cows were grazing using the fire to get them to use areas that they didn't want to use before. And so here, this map is the cold spots. This is where, from the GPS data, the areas that the cattle avoided are blue. The areas that are this tan color are the areas they were kind of neutral towards, and the areas that are red are the areas that they had a high preference for. So we put our burn units as much as we could in the areas that they avoided, the blue colors. And then the next year we put those cows back in there with GPS collars, and you can see that those areas have now turned to red. So they're hot spots. They're preferred locations in the pasture. Another thing that we found with this research is that we actually pulled the cows away from the creek. So they spent less time grazing along the creek, which can have negative impacts on water quality. When cattle are in creeks and stuff, they can put E. coli. You get E. coli from their feces in the streams. And so we actually ended up pulling cows away from the streams using this strategy. Okay, so how do wildlife think about this whole strategy of burning and allowing animals to concentrate their grazing? Well, what we've created is we create an area that has very short vegetation like this. There are certain wildlife species that like that. Then the next year after that, you have an area that has a lot of broadleaf plants, a lot of wildflowers. A year after that, you have a mixture of broadleaf plants and grasses, and the last year, you have a lot of very dense, thick grass. And so what we found was that different bird species like different times since fire. So a killdeer or a lark sparrow, killdeer, they like to nest like on a rock. I see them in our riding arena at the house. They want no grass anywhere. And so, of course, they were attracted to this really short grass. Then the upland sandpipers were a little bit later. Grasshopper sparrows are right in the middle. We have eastern meadowlarks, which you've probably seen a bunch of eastern meadowlarks. They're those ones with the big yellow throats. They're so pretty. Those prefer kind of an intermediate time since fire. And then we have dick sissels and hensel sparrows. Those grassland birds, they want very thick vegetation. And it's hard for us to get that in Oklahoma unless we just don't graze a pasture for a full year. But we can get that with this type of strategy. Oops. Same thing with wintering birds. And why do the birds matter? Well, grassland birds are the most significantly declining birds across the world. More than any kind of tropical birds, wetland birds, grassland birds are declining. We found the same thing with butterflies. Different butterflies prefer different numbers or different habitat type. Same thing with prairie chickens. Prairie chickens, they want to lek here when they're during the breeding season. They want to raise their chicks here because they like to eat all the bugs that this attracts. And then they want to nest over here where there's lots of dense grass. And that's insects. Okay, another thing that we found is that you get lots and lots of plant species diversity. So this is another research project that we did where we burned in different months. We had all these little plots that we burned. We burned a plot every 2 months, and we ended up tracking 117 flowering broadleaf plants in there, doesn't include any of the grasses, in 2.5 acres. And that's just an astounding amount of diversity from the fire. There we go. So how would you do this? You just divide your pasture in more than one patch for a burn. So sometimes we use ranch roads as a fire break. Sometimes we'll use a creek. You can use, you can put in either a dozed line or a mowed line. And if you do a mowed line, then you can just wet that down before you light near it. So a wet mowed line. Those are all different strategies, but basically you just divide the pasture into as many patches as you want the fire return interval. So if you want the whole pasture to burn over a 3-year period, you divide it into 3 patches, and you'd burn one patch 1 year, one patch the next, and one patch the 3rd year. I'm going to skip this and this. Sorry. We did find that when you burned and clipped seedling grasses, they actually grew more than if you just clip them alone. And so that's simulating grazing. And so these grasses are actually responding positively to this combined treatment that they're experiencing. Sorry, I meant to take this out. Okay, so the last thing I kind of want to say is that this is how animals used this land for thousands and thousands of years. And that's why it's working so successfully in creating habitat for so many different wildlife species. These are historical accounts of different animals that were found across the Great Plains. Of course, there were bison everywhere, but there were elk. There was elk at the Cimarron River. Washington Irving talked about elk in 1832. They also talked about pronghorn. So there was elk, pronghorn, bison, also, of course, white-tailed deer. They were all living here. And we know that all of those species are attracted to areas that have had fire. And so historically there was wildfire burning frequently, and those animals were following those burns and grazing on those burns. And so that's why it works so well, because it's been going on forever. Okay, I'm gonna skip this one too. If you're interested in looking at how your pasture may have changed as far as woody cover, there's a tool called the Rangeland Analysis Platform, and it's an online web page that you can look at, and you can delineate your pasture and look at how a pasture may have changed in woody cover. It'll generate something like this, and it'll even generate a calculation for how much grass biomass you're growing in that pasture. And you can look at the tree cover and the grass production. You can even use a stocking rate calculator in this tool. It's called the Production Explorer in the Rangeland Analysis Platform. So if you've never calculated a stocking rate, that's something that you can try and just see how close you are to grazing the number of animals that it's recommending. Once you delineate the pasture, it'll tell you how many acres it is. Then you just put in the size of the animals that you're grazing in there, what their weight is. You'll just say how much their intake would be, which is probably 2 or 2.5% of their body weight, and then how many days you're going to graze them. If you're going to graze them 30 days, then you just put in 30. If you're going to go in there twice, say you're going to go in there twice for 2 months, then you just put the total number of days for 4 months. And it'll tell you how many animals it can support for that time period. It'll also tell you how many it could have supported historically. So this is a pasture in western Oklahoma. It's not as productive as what you guys have up here. But this pasture, it's showing how many cattle it could have, how many cows that weighed 1,300 pounds it could have supported year-round in different years, so going all the way back to 2000. And you can see 2011 was super low, only 3 animals that year. Then 2015 was pretty high. I think it was 10 animals that year, but the average was 7 animals in this pasture. This pasture probably grows about half of what your pastures do, but this is if we were grazing 1,300 pound cows year-round. So I would check that out. It's pretty simple to use, and I know the folks in the NRCS offices and Extension, we're starting to use this a little bit. Another thing is that we post really frequently about land management, and so we're on social media if you're active there. So on Facebook, X, and Instagram, we're at Oklahoma Lands, and so you can check us out there. We do lots of plant ID, grazing management, prescribed fire, all these different types of topics too. So with that, I'd be happy to take any comments or questions or concerns that we're going to burn the world down.